Alright, so here we go. We have two more examples then left to do here in section 3.1. So we'll make sure we get these done before you can do your homework. So the problem we're looking at then is 6 over x minus 4 quantity squared. So again, we start by looking for what the domain is. So in this case, it's everything except for when x is equal to 4. So my domain then is going to be from negative infinity to 4, and then again from 4 to infinity. Now this is the part where the book says to analyze the original function. So you start by getting the domain, and then finding any x or y intercepts if they have them. Well, the numerator is never going to equal 0, so therefore we have no x-intercepts. Alright, the y-intercept is the easy one. We just plug 0 into our function. So I have 6 over then 0 minus 4 quantity squared, which is then 6 over 16, which reduces then down to 3/8. So let's go ahead then, let's plot then that point on our graph. So 0, 3/8, that's going to be then right about there. So hopefully you can see it. Alright, now let's go ahead, let's talk then about vertical asymptotes. The vertical asymptotes is where the denominator is equal to 0. So this case then, it's going to be then x equals 4. So we can go ahead, draw in then our vertical asymptote at x equals 4. Again, as I go through, I generally mark these down as I go along so I don't forget anything. So I got my vertical asymptote there at x equals 4. Now again, since the degree of the numerator is smaller than the degree of the denominator, that means then that we have a vertical asymptote, and that vertical a horizontal asymptote, and that is going to be then at y equals 0. So that's going to go ahead, go then across the x-axis there. Okay, so I have a vertical and a horizontal asymptote. The last thing I need to do then is to go ahead and determine the behavior around my vertical asymptote. So we're looking then at the limit as the rational expression approaches 4 from the left, and the limit then as the rational expression approaches 4 from the right. So filling in then these values, this goes from 6 to 24. Oh, this should go the other way around. Sorry, my bad on that. 6 and then 7.4074, and then up to 28. So the limit then as x approaches 4 from the left, we're going from 6 to 7.4 to 24. That is then going to head towards infinity. In a similar fashion then, alright, coming in from 5, this then goes from 6 to 24, and of course my calculator shuts off, and then blasts off to 600. So this too then is also heading towards infinity. Okay, so marking that then on our graph, we are looking then like that, again just to give us a rough idea of what the graph then will look like. Now that we finished analyzing the original function, we need to go back and we need to now analyze the first derivative. So I have then 6 times x minus 4, quantity then to the negative second power. Alright, so as I look at this then, I'm going to go ahead, I'm going to take then that first derivative, and again using the chain rule, this will be then a negative 12, x minus 4 to the negative third times then 1, which then gives me negative 12 over x minus 4 to the third power. Now, as we take a look at this then, okay, we need to find then our critical values. Now, our critical values, okay, that is where the first derivative equals 0 or is undefined. Now, for this case then, as we take a look at this graph, okay, we can never get the denominator or numerator to equal 0. Okay, so therefore we will not have any critical points in which the first derivative equals 0. We only have the undefined value when x equals 4. So of course we're going to go ahead, we're going to pick our favorite values that are smaller than our critical point and bigger than our critical point. So I'm going to select x equals 0, and I'm also going to select x equals 5. At x equals 0, our prime then of 0 is going to go ahead, and that is going to be a negative 12 over then a negative 4 to the third power, which is a negative 12 over a negative 64. Now I know that reduces down. Both are divisible by 4, so that's going to be then 3 over 16. And then negative over negative will make it into a positive, so it'll be then a plus. Okay, and then at 5, r prime of 5 will be a negative 12 over 5 minus 1 to the third, which is a negative number. Okay, so by all accounts, this should be a local max, but we know that we have a vertical tangent line there. So by our graph, we know then that we're going to get a vertical asymptote in which we're getting the graphs approaching from both sides like that. Alright, but we can get some further information. We know then that this graph is going to be increasing as we go from negative infinity to a positive 4. Okay, and then we also know that it's going to be decreasing from 4 to infinity. Okay, so again, going back, we have then those rough sketches. So this kind of agrees with what we said. We're going to be increasing. Now we have a horizontal asymptote, so we're going to be approaching that horizontal asymptote, and as we get closer and closer to 4, we're going to then skyrocket off to infinity. All right, let's see how well I can do this one-handed. All right, because you know I can do it so well two-handed too. All right, that was a little bit of sarcasm. All right, so we got the graph going then that direction, and then we're going to be decreasing from 4 to infinity. All right, and it'll come then down like this and approach that horizontal asymptote. And then there's our graph. All right, I will go ahead and I will upload these notes to go along with then this video.